This video is going to go over all the problems from the review for Unit 11 Probability. And so you should have already gone through all of the lessons and done all the practice problems already. And then if you would like, you can go over a review problem and then push play on the video to compare your answers to what I have, or you can do the entire review first and then compare your answers to this. Either way, but I'd like you to be doing the review problems before you watch the video on the review problems. So with that said, let's go ahead and get started. Number one is giving you Venn diagrams and is asking you to shade in the regions based on the set notation. So in the first one, it says we want to shade in the region A union B. Remember, the word for union is or, A or B. Now, something that needs to be emphasized here, because a lot of students make this mistake, when you hear the word or, you are thinking and or, okay? You want to make sure that you're including the part that is A and B as well as A or B. It's not an inclusive or, which means it can either be this or this, but it can't be both. No, it's this or this and both. Okay? Remember what I've told you in the past, when you see the union or the or, you're thinking three pieces. So you're going to shade in three regions of this Venn diagram. And when we shade in an or, we're going to shade in all of the first thing. So we're going to shade in all of A. All right? And so that's an A. And that's also A here. So this is all of A. That entire circle's A. And we're going to shade in all of B. Okay, now you'll notice when we shade in all of B, we've already shaded in part of that when we shaded in A. So we don't need to shade it again, but those three regions, the moon, and the football, is A union B. For B, it says not A, intersect B. Not A and B. So that means we want the region that is both not in A and it is in B. So remember, when you hear the word and or intersection, you're thinking one piece of the Venn diagram. So what piece represents not A and represents B at the same time? Well, we know we're not going to shade in anything in A because we don't want A. So we're either going to shade in the leftovers or we're going to shade in this football. Well, do we want the part that's not B, or do we want the part that is B? We want the part that is B, so we're going to shade in that region. Okay, so it's just the moon there. And again, one piece. For C, it's saying shade in A union, not B. A union, not B. Again, union is three pieces, so we need to shade in three pieces of this Venn diagram. We're going to start off by shading everything that isn't in A, okay? Everything that's in A. So we've got the entire circle A. And then we're going to shade in everything that is not B. So that means everything outside of B. And again, notice that we are going to shade in stuff that we've already shaded in before, so we don't need to do it again actually. And you'll notice as we shade this, that this is actually three pieces of the Venn diagram. It's one of the moons, the football, and then the leftovers. Okay, so again, keep that in mind. Anytime you see a union, you're going to shade three pieces in, and anytime you see an intersection, you're going to shade one piece in. So that leads us to option D, or question D. We're going to shade one piece in because it's an intersection. We're looking for the piece that is not A and is not B. So we're shading in anything that is neither of those. So it's just the leftover stuff. Okay, so keeping in mind, maybe another way to think about this, when you are looking at unions, you are going to color in the first thing, you're going to color in the second thing, and the union is everything that you've colored. Okay, if you're going to color in an intersection, well, color in the first thing, color in the second thing, and an intersection is anything that is colored twice. So if you color in the first thing using one color and then color in the second thing using another color, the intersection is the piece that has two colors in it. Okay? It's not everything that's colored, it's just the piece that has both colors in it. All right, going on to question number 2. It says each letter of the word mathematics is written on a card and placed in a bag. If the 10 cards are mixed up and one is randomly selected, what is the probability that the card selected is a vowel? Oh no, I need to know what a vowel is. Remember, a vowel is A, E, I, O, U, and sometimes Y. So, first thing we need to do is identify our vowels. Well, our vowels are the A, the E, the A, and the I. So the next thing we need to do is identify our sample space. Our sample space is all the possible things that you can get out. Well, I can pull out any of these letters, and notice there are 2 M's in the bag. There are 2 A's in the bag. There are 2 T's in the bag. So you're going to have 2 cards with an M on it. You're not going to just have one M card. Okay? So there is a total of 4 vowels out of a total of 11 letters. And then it says write your answer as a reduced fraction, and that's as reduced as it gets, so that's our answer there. B, it says what is the probability that the card selected is a consonant? Well, remember, a consonant is everything else. It's everything that's not a vowel. So it's going to be the M and the T and the H and the M and the T and the C and the S. So we count those up and we end up with 7 of those out of 11. So we could do it that way. But remember, the other way is to notice that these 2 events are complements to each other. In other words, they fill out the entire sample space. So this event plus this event will give us a total of 100%. So you could have just as easily said, okay, well, 11 minus 4, the total minus 4 gives me 7. So the leftover region would be all our consonants. For number 3, we have a Venn diagram here that displays information about whether people prefer hamburgers or hot dogs. The people that prefer hamburgers are represented by B, and the people that prefer hot dogs are represented by D. Find and express each of the following probabilities as a reduced fraction. Now, before we do this, I want to note that this Venn diagram is actually not complete. Okay? This is how we normally see Venn diagrams, but we also want to include 3 more numbers that represent totals. Okay, so here we have just B, we have B and D, we have just D, and then we have everything that's not B or D. But we don't have the totals of each of these, so we're going to put the totals in. The total amount of people that like hamburgers is 19, and the total amount of people that like hot dogs is 13. Okay, now the total is going to be 30, because we're going to add up all of the inside numbers. So 12 plus 7 plus 6 plus 5 gives you 30. So now we can start doing a probability. In A, it says, what is the probability that you get B given that you have D? In other words, this is a conditional probability. The line here means if. Okay? So the second thing is our denominator. And the first thing is the part of B that's inside the denominator. So when we set this up, we're going to put it over 13 because we're narrowing our focus down to just the hot dogs. If I look within just the hot dogs, there are a total of 13 hot dogs. So that is my sample space. Now what do I want? I want the hamburgers inside the hot dogs. So how many hamburgers are inside the hot dogs? That would be 7 out of 13, and that's our answer for that one. For B, this is not conditional probability, which means the sample space is the entire group of people. So there are 30 people, okay? And we can see that this sample space will always be the total if as long as you're not doing a conditional probability. The only time your sample space changes, the only time the denominator changes is if you're doing conditional probability. So if you hear the words if or given that. In B it says, what's the probability of B intersect D? So what part is B intersect D? Remember, intersect is one piece. So what piece is the intersection of those? Well, that's the 7. That's B intersect D. So that's our probability for that. There are 7 out of 30 people that prefer that like hamburgers and hot dogs. All right, for question C, what's the probability that a person likes hot dogs? Well, again, the sample space is going to be 30. How many people like hot dogs? Well, 13 people like hot dogs. You can see that we want to include everything that's a hot dog, so 7 plus 6, which is the 13. All right, for D, it says, what's the probability that a student does not like hamburgers? That doesn't mean that they have to like hot dogs. It just means that they don't like hamburgers. So again, the sample space is 30. How many of you do not like hamburgers? Well, that would be the 6 and the 5. So that's going to be a total of 11 there. And then the last one in this problem, it says, what's the probability that a person likes hot dogs or hamburgers? Remember, or implies 3 pieces, and so that would be 12 plus 7 plus 6, which is 25 out of 30, which reduces to 5 out of 6. Now, remember, there's another rule. There's the addition rule when we're talking about unions or intersections. How could I get 25? How can I get 25 in a different way other than adding 12 plus 7 plus 6? Well, I could take the total of B, the total of D, and when I add those up, I end up with 32. But then when I add those up, remember, I'm adding their intersection twice when I do that, so I need to subtract the intersection. So we would say 19 plus 13 minus 7, and again, that's going to give us 25 out of 30, which is 5/6. For question number 4, we're given a table here, and it says a school was interested in how students get lunch. Students of all levels were surveyed. Some students bring lunch from home, some students get school lunch, and some students use Postmates. And we want to complete the table by writing the totals in the empty cells. Well, that's easy. I'm just going to fill those in. You guys can check your addition, but this is what you get for your sums of each of those. One thing you want to make sure is that when you add these 4 totals up, that you end up with the same total as if you add these 3 up. So this row has to add up to a total of the same as this row. Part B, it says, what is the probability that a randomly selected student is a sophomore who brings lunch from home? So the way we would write the probability statement here would be the probability of a sophomore intersects home. Okay, so we want the sophomore and we want home. So notice our sample space is going to be 503 because that's the total, and 43 is the group of people that are sophomores and bring their lunch from home. Now it says write our answer as a decimal, so we're going to use our calculator, and we end up with 0.085. For C, it says what is the probability that a student uses Postmates if they are a senior? Notice the key word here is if. So this is a conditional probability. We would write this as the probability of P given senior. All right. Now our sample space is going to change now. We're not looking at the entire school. We're looking at only seniors. And so that would be out of 84. So out of the 84 seniors, how many of them get Postmates? Well, that would be 41. So 41 out of 84, calculator produces 0.488. And then D, it says determine the value of the probability of J intersect H and explain its meaning. So this is going to be the probability of a junior and home. Well, what does that mean? We write that out as the probability that a student is a junior who brings their lunch from home. And so our sample space is going to be 503. And how many of these are juniors who bring their food from home? That'd be 32. So it'd be 32 out of 503, which is 0.064. And again, the meaning is the probability that a randomly selected student is a junior who brings their lunch from home. I know that this can get a little confusing in terms of the conditional probability versus the and probability. But we are in the and probability, we're saying that we want something and something to occur out of the entire group. Whereas the conditional probability is the same kind of thing. We want something and something to occur, but only within a subgroup. Okay? So let's go ahead and look at number 5. Again, another table, and it's filled out for us this time. Okay? A store noted the number of shirts and pants sold in 1 week along with the color of the clothing. What is the probability, rounded to the nearest thousandth, that a clothing selected at random was blue or a shirt? So we're going to write this out as probability of B union S, blue or a shirt. Now I should have probably clarified B will be blue because we also have black there. We couldn't even put BL because they both start with that. So we should write it out. Probability of blue or shirt. So remember the sample space is going to be the entire thing, which is 227. But how many shirts do I have? Well, I have 22 there, 13 there, 32 there, and 52 there. And then how many blue things do I have? Well, I have the 13 and the 46. So I don't want to include the 13 twice, but basically everything that's circled there is going to be my event space. So we could add up all of those 5 things and put that over 227. And so we end up with 165 out of 227, and then we'll plug it in our calculator and get our answer. But remember, because we have a union or an or statement, we could have also figured it out by taking the totals of the blue and the shirts, so the 119 and the 59, adding those together. But again, when we do that, we are adding the 13 twice, so we don't want to add it twice. We're going to subtract one of those times, and so when I put that all together, I get the same answer, 165 out of 227. For number 6, now we're looking at geometric probability. It says find the geometric probabilities and write your answers as percentages. So in part A, we want to find the probability of the shaded region and then the unshaded region. So what I have to do is find the areas of each of these pieces. So I'm going to find the area of the rectangle, which is 15 times 18. That's 270. And then the area of the triangle will be 1/2 of 10 times 12, which is 60. And now the sample space here is going to be the entire shape. So that means the rectangle is going to be my sample space. And then my event space is the shaded region, so that'd be 60. That's pretty straightforward. That converts to 0.222, or because we want a percentage, we write that as 22.2%. Obviously, you can be more accurate than that, 22.2222%, but irregardless. Now, the second part, it says, what is the probability of the unshaded region? Well, I didn't calculate the area of the unshaded region here. I only calculated the area of the whole thing and then the area of the triangle. So to find the area of the unshaded region, I can just take these two values and subtract them. So we would end up with 270 minus 60, which is 210. And then we can put that over the whole thing, which is 270. And then that would be 0.778 or 77.8%. But the other way to do this is to recognize that the shaded region and the unshaded region are complements to each other. And remember, complements, when added up, give you the entire thing, the whole sample space. Since the entire sample space is 100%, and I know the shaded region is 22.2%, then I can just subtract the 22.2% from 100% and end up with my probability of the unshaded region. So either way works for that part, for that problem. All right, for B, now the shaded region is the outside. It's not the circle. So again, we're going to find the area of the circle. Remember, area of a circle is pi r squared, so that's 81 pi. We're going to find the area of the square, which is going to be 18 times 18, because if the radius is 9, that means the entire length of the square is going to be 2 of those, the diameter. So 18 times 18, which is 324. Now for me, it's easier to find the probability of the unshaded region because the unshaded region is the circle. So I'm going to do that first. It's going to be 81 pi over 324, and then typing that in my calculator, I end up with 0.785, which as a percentage is 78.5%. We could do either option for finding the shaded region. We could subtract the 81 pi from 324 and then put that result over the 324, or we could just take our unshaded percentage and subtract that from 100, so we'd end up with 21.5%. For number 7, we're given a Venn diagram, and C is the event that a person likes cats, and D is the event that a person likes dogs. The probability of various combinations of these events are shown in the Venn diagram. If a person prefers cats is selected, what is the probability that the person does not like dogs? Write your answer as a decimal. Well, again, we're missing a bunch of pieces here, so we're going to add up our total cats, which is 54%, because we add up this piece of the cats and this piece of the cats. And the total dogs is going to be 0.23 plus 0.46, which is 0.69. Remember, we're missing two other numbers here. Because these are already written as probabilities, we know that the total here is going to add up to 1.00. And so we can figure out the leftovers by subtracting these three numbers added up from 1.00. Well, when I add those numbers up, I actually get 100%. 0.31 plus 0.23 plus 0.46 is 100%, which implies that there is nothing left over. So that means in this survey, everybody in this survey said they like a cat or they like a dog, or they like both. But nobody said, I don't like either one. Anyways, the total is 1.00 there. And now let's read the question carefully. If a person who prefers cats is selected, what is the probability that the person does not like dogs? Notice we are reducing our sample space to only cats. We are not looking at the entirety of the Venn diagram. We're only looking at cats as our sample space. So we would say the probability that, first of all, given that they like cats, and then what is the probability that the person does not like dogs? So we'd say D not. Okay? So now, this is conditional probability. So that means our sample space is going to be the total cats, which is 54. And then we want the part of that is not dogs. Well, the 0.23 is liking dogs. So it's going to be the 0.31 that does not like dogs. And then type that in our calculator. We end up with 0.574. And it said write it as a decimal, so we are done. For number 8, if a student at Cedar Middle School is selected at random, the probability that the student plays soccer, that's a little typo there, plays soccer is 0.42. The probability that the student plays volleyball is 0.37, and the probability that the student plays soccer and volleyball is 0.29. What is the probability that the student plays soccer or volleyball? So I'm going to write down some probabilities here. It first said that the probability that a student plays soccer is 0.42. The probability that a student plays volleyball is 0.37. And the probability that a student plays both, so the intersection of those, is 0.29. The question is, what is the probability that a student plays soccer or plays volleyball? Again, when you're thinking about or, you're thinking and or. So if they play either one, or if they play both. So remember, we have an addition rule that puts all this together. We can say that the probability of the union is equal to the probability of each singular event minus the probability of the intersection. I got a little typo here. Let me fix this real fast. So it should be minus there. Now we can just plug in our values and simplify. So we would end up with 0.42 plus 0.37 minus 0.29, and then that simplifies to 0.5. Now, that is the addition rule. If you didn't remember the addition rule, you could have drawn out a Venn diagram or a table of some sort to see how this works. So we have soccer players in one circle, we have volleyball players in another circle, and then we're going to fill in our values. So notice the probability of soccer is 0.42. Most often, I'm telling you right now, the biggest mistake in this unit is misplacing the S, okay, and the V. Students will put the 0.42 in this region. That is not correct. The 0.42 is the total number of, or the total probability of soccer players. So if I put it here, this region is not the total S. The total S is represented by both of these pieces right here. So we have to put that at the bottom, 0.42 at the bottom. Same thing with volleyball, 0.37 at the bottom. Again, this is the biggest mistake in this unit, and it goes across the board. The students that are getting A's in the class and the students that are not doing so well in this class make the same mistake. The total has to go on the bottom. All right, with that said, the intersection is 0.29, so that's going to go inside there. And then we can figure out some leftover stuff. We can figure out what these missing pieces are. We know that these two pieces have to add up to 0.42, so we'll just subtract those. We end up with 0.13. And then again, these two pieces have to add up to 0.37, so we subtract that and we get 0.08. And then our question is, what is the probability of S union V? Remember, union is three pieces of the Venn diagram, and the union of S and V would be these three things here. So we're going to add up 0.13 plus 0.29 plus 0.08. And when we do that, we end up with 0.5 again. All right, number 9. A school took a survey of 400 students of the classes they were taking. Of those students, 244 are taking PE, 236 are taking Spanish, and 112 are taking Spanish and PE. A student is selected at random. Give, and then your answer should be written as reduced fractions and percent to the nearest tenth. I don't think I did that when I wrote all these out, but that's okay. Part A, it says draw a Venn diagram to represent this information. Well, the first thing I know is that we have a total of 400 students, so I want to put that outside the box so I know the total inside. Now, we know that we have PE and we have Spanish, so I'm going to use P and S to represent those. We have 244, let's see, 200 and, come on now. We have 244 taking PE, so we can put that there, and then the 236 taking Spanish, so we can put that there. Wait a minute. Mr. Bunya, you just told me that the total numbers don't go in those areas. You're right. You see, I'm putting these numbers here to emphasize that it is wrong, okay? The 244 is the total number of students taking PE. This region is not everybody taking PE. Both of these combined are, so we need to erase that, that's wrong. And we need to put the lines at the bottom. The total number of PE is 244, and the total number of Spanish is 236. Please don't make that mistake. All right, and then it says that 112 are taking both Spanish and PE, so it's going to be in the middle. Again, we can figure out these pieces by subtracting 112 from 244, which is 132, and then subtracting the 112 from the 236, which is 124. And then we can figure out what's left over by adding all three of these numbers up and then subtracting them from 400. When you do that, you end up with 32. That means there's 32 students that are not taking PE or Spanish. All right. For A, it says find the probability that a student is taking PE or taking Spanish. Again, we have an or, so we're going to write that as a union. So P of PE union Spanish. Again, three pieces. The three pieces are the 132, the 112, and the 124. So we'll add those up and then put that all together, and you end up with 23 over 25 as a reduced fraction. And then I'm not going to put that into a percent. You guys can do that on your own. For B, it says, what's the probability that a student is taking Spanish but not taking PE? Probability of a student taking Spanish but not PE. The way we would write that is P of S intersect, not P. So remember, when we have an intersect, we're talking about one piece. And even if you didn't see this notation, you should be able to identify the region that is Spanish but not PE. Well, that would be this piece, 124. Again, one piece out of the entire puzzle when you have an intersection. Reducing that, you end up with 31 over 100, which is 31%. For C, it says, what's the probability of a student taking neither class? Well, that's pretty easy. We'd say the probability of not P. Did I read that wrong? Oh, I think I read that wrong. Let's see here. Okay, for C, it actually says, what's the probability that a student is taking neither? So we would write that as P of not P intersect not S. And so we can see in the Venn diagram which group is not taking either PE or Spanish. Well, that's this out here. That'd be 32 out of 400, which reduces to 2 out of 25, which reduces to 8% if you're going to put it into a percentage. For D, it says, what's the probability of a student not taking PE? So the probability of a student not taking PE would be written as P of not P. And so the region that is not P is actually 124 and the 32. So we'd add those two things up, and we'd end up with 156 out of 400. That reduces to 39 out of 100, or 39%. For the last one, it says, what is the probability, or sorry, it says determine the value of P of S given P and explain its meaning. So we want S given P. Again, this is conditional, so our sample space is going to change. Our sample space is only going to be P, which is a total of 244. And then for this condition, we are only looking at the S's inside of P, so that would be the 112. And so that can reduce, but it says write it as a percentage, so I'm going to put it in my calculator and get 0.459, which is 45.9%. The second part of this, it says explain its meaning. Well, we would say that the probability that a student who is taking PE is also taking Spanish is 45.9%. Or we could say it like this. We could say the probability, sorry, let's see, let me rephrase that. If a randomly selected student who is taking PE is selected, the probability that it will be a Spanish taking student would be 45.9%. Or we could say the probability that a student is taking Spanish given that they are taking PE is 45.9%. So a couple different ways of saying that. But the key words that you have to have in there is something about if or given. Let's go ahead and go on to number 10. Number 10 is some review problems from Math 1. We're just solving for x here. And of course, there's a couple different ways of doing this. What I did was I subtracted 10 from both sides. So I got negative 16 on the one side. So x over 5 equals negative 16. And then I multiplied by 5 on both sides. So you end up with x equals negative 80. Another thing you could have done first is to multiply both sides by 5, but you got to make sure you distribute that 5. So you would have gotten x plus 50 equals negative 30, and then we would have subtracted the negative 50 from both sides. For b, I think the best thing to do first is to distribute, so we'd end up with 3x minus 15 equals negative 2/3 x minus 8. And because I don't like dealing with fractions, what I'm going to do is multiply everything by the denominator there. So I'm going to multiply everything by 3. Because I do it to one side, I have to do it to the other. And then I'll go ahead and distribute again. So 3 times 3x is 9x, and 3 times negative 15 is negative 45. The negative 2/3 x times 3 cancels out the denominator, so you get negative 2x. And the negative 8 times 3 is negative 24. Then we'll add 2x to both sides and get an 11x minus 45 equals negative 24. Add 45, so we get 11x equals 21. And then divide by 11, so we end up with 21 over 11 as our final answer. For number 11, again, review problems, basic review problems, not even trigonometry here. We're just looking for the missing side length. And so because this is a right triangle, remember we can't do the Pythagorean theorem unless this is a right triangle, but because it is, we can do the Pythagorean theorem. Remember, it's leg squared plus leg squared equals hypotenuse squared, so 12 squared plus 9 squared equals x squared. Got 144 plus 81, which is 225. We'll square root both sides, so you end up with x equals, got to be careful here, technically x equals plus or minus 15. But because we're talking about the length of a line segment, we are only looking at the positive value because length can't be negative. For b, same thing, but this time the hypotenuse is given, so we have to set it up correctly. It's 6 squared plus x squared equals 10 squared, or 36 plus x squared equals 100. We'll subtract the 36, we end up with 64, square root it, so we end up with plus or minus 8 again. And again, it's only the positive version because we're talking about length, so it's 8 inches. And then the last problem, number 12, it says find the slope of the line that intersects these 2 points. Well, we have a couple ways of doing this. We could plot these points, but these are really big numbers. Or we could just plug it into our slope formula, which is y2 minus y1 over x2 minus x1. So that would be 24 minus negative 2 over negative 38 minus 14. And so you end up with 26 over negative 52, and that reduces to negative 1/2. That wraps up this review. If you guys have any questions on this, please make sure you log into Zoom and ask me so that we can go over anything that you need help on. But otherwise, you should be ready for your unit test, and I will talk to you later.